In this video, we will talk about how to find area between the curves. So basically, this is pretty much all you need to know. We are basically finding this this amount of area between these points. So from A to B. This is the formula that you will be using in finding area under the curve. I put the T and the B for top and bottom because we're trying to find this top to this bottom. And this is for in terms of x. So from right to left dy. So let me give you an example. Trying to find the between these 2 points from x equal to 0 till x equal to 2. So how do we do that? Let's start off by putting in our formula. It's going from 0 to 2. So that's why 0 goes on the bottom and 2 goes on the top. And the top function would be 3x minus x squared. And the bottom function would be x, since x is the bottom function, dx. So this is easily, you can subtract 3x by x. That will be 2x minus x squared dx. Now we have to integrate. This is basically just integration at this point. So 2x squared over 2 minus x 2 plus 1 equals 3 over 3. 2 cancels out, and we get x2 minus x3 over 3. We're not finished yet though. We gotta plug in the two values. So 2 first. Now plug in 0. This will cancel out to be 0. And we are left with 4 minus 2 to the third power. That will be 8 over 3. Final answer will be 4 over 3 square units, because we're finding the area, so we have to put square units. Let's do one more. So let's try in terms of x now. So in this problem, we're going to find the area between these two x functions. So remember, we have to calculate this from left to right in terms of y. So in this case, it will be from 0 to 3. So the first function that goes first would be 2y, since it's it's going right first. 2y minus y squared. Then we gotta subtract the left function. We can we can distribute the negative to this function, so it will be minus y squared minus times minus equals positive, so positive 4y dy. And we were left with this function, dy. So 2y minus 2y squared plus 4y dy from 0 to 3 in terms of y. So now let's integrate. So this is the same thing. It's really simple, guys. 2y squared over 2 minus 2y to third over 3 plus 4y squared over 2 cancels out, divided by 2, so it will be equal y squared minus 2 to the third y third plus 2y squared. Now we have to plug in our values. This will cancel to 0, and 9 minus 2 over 3. 3 to the power of 3 is 27 plus 2 times 9. So we'll be left with negative 18 cancels out with 18. We left with 9 square units. So the area of the region that lies to the right of the y-axis and to the left of the parabola x equals 2y minus y squared is given by the integral 0 to 2, 2y minus y squared dy. So find the area of the region. So guys, this is very simple, guys. It might look hard, but it's not. So let's start off with step 1. As you can see, this is in terms of y. So immediately we can just We don't have to do any fancy stuff. And let's just start off. So from the limits are from 0 to 2. Since it's going from y equals to 0 to y equals to 2. From right here. And we want to find the shaded region, so let's put in the function. 2y minus y squared dy. Now, we just have to integrate, guys. Really simple, man. So 2y squared minus over 2 and y cubed over 3. 2 cancels out and we are left with y squared minus y cubed over 3. So then we have to plug in those y values. So this is step 3. So plug in the y values. From 0. 2 squared is 4. 2 to the power of 3 is 8 over 3. And we will try to convert this into simpler terms. So 4 over 1 times 3. 12 over 3 minus 8 over 3 equals 4 over 3 square units. Let's look into the next problem. Here's another problem in which we have to find the shaded region, but there's something wrong with this problem. We have to find the area of 2 shaded regions. So this is double the work, but honestly, guys, this is still easy, guys. Like, well, to start off, we can see that these two areas are symmetric, and that what does that mean? Well, it means that they are equal to each other. So when we do the integral, we can put 0 to 2, 2, because there's 1, 2 areas we need to find. And you can only use this in when they are symmetric. If they're not symmetric, then don't use this method. But this is a method you only have to use when the areas are like equal to each other. So yeah, x minus x over 3, x to the power of 3 minus 3x, because from 0 to 2 we can see that y is from the top and x3 minus 3x is in the bottom. So it goes from top to bottom. Now we have to distribute the negative. So this becomes negative x to the power of 3. Negative times negative equals positive. So positive 3x. Now let's integrate. So x squared over 2 is 4 over 4 plus 3x squared over 2. I'll plug in the y values. 4 divided by 2 is 2. 16 over 4 is 4. And 12 over 2 was 6. So negative 2 plus 6 equals 4. But we're not done yet. Still have to multiply by 2. Because this is a symmetric, and we have to multiply by 2. So 4 times 2, because we're going to be 8. And this is our final answer. Now let's look at the next problem. So in this question, it says set up, but do not evaluate an integral representing the area of the region enclosed by the given curves. So we have two functions, y equals 2 to the power of x and y equals 3 to the power of x. And we got one other function, x equals 1. So in this case, we don't have to graph anything, we just have to set it up. So let's try to do that. So we only have one value, x equals 1. And given that this question is going to be given in terms of x, we have to find the other x value to make the integral. And to do that, we will set these two up. So what do you notice about these? Both of them are equal to y, so we can equal them together. 2x with 3 to the power of x. Now, in order for this to work, we have to find one other value, so both of them can be equal to the same value. So we already got one value, so x equals 1, so we need to find the other value. So what value could make them be equal to each other? Let's try x equals 0. So plug in 0 for x. Anything that's to the power of 0 will be equal to 1. In this case, they are both equal to each other. So x equals 0 is the other value. Now we have to set up our integral. So we have x equals 0, and we got two functions, 0 to 1. But how do we figure out which function comes first? Well, guys, we're gonna have to graph it. That's the only way to find out. Because we either have to find out if one function would be top or one function would be bottom. So we have to do more work. But this is very simple. So let's make a XY chart. Let's just put the first three numbers. So 0 to 2, do y equals 2x. 0 plugged into x would be 1. 1 plugged into 1 equals 2. And 2 plugged into x would be 4. Now let's try with the other function. 0 plugged into x equals 1. 1 plugged into x equals 3. And 2 plugged into x equals 9. So let's try to graph these. So as you can see, guys, we are going to have to find this shaded region. And as you can see, 2 to the power of x would be going first. Then it will be 3 to the power of x because 2 to the power of x is on top and 3 to the power of x is on bottom. So we now have everything to set up our integral, and let's try to figure this out. So it's from 0 to 1, and our top function would be 2x. Our bottom function would be 3x. So our final answer would be 0 to 1, 2 to the power of x minus 3 to the power of x dx. So let's look into this last question. Here it says sketch the region enclosed by the given curves and find its area. So in this situation, we have to graph and we have to find the area of the shaded region. So we are provided two functions. So we need to find our limits or our values. So, and given it is in terms of y, we have to find these y values. So let's, our first step is going to be equaling these values. We have to find the x values or the y values that will give us this shaded area. So final answer would be 18 equals 2x squared divided by 2 x would be equal to 3. But guys, we have to realize that when you square root a number, it's always going to be plus and negative. So x would be equal to plus negative 3. And these are the two values for our limits. So our next step is going to be graphing. So let's put the t-chart again. Plug in any three values that we can use. I would say put -3, 0, and 3 because those are going to be the easiest. And plug in the values into the x values. So here we have our y values. And now we are going to graph it. So let's graph this. So guys, we finished. So we have to find the area of this region. Our top function is y equals 12 minus x squared, and our bottom function is y equals x squared minus 6. Top value is 12 minus x squared minus squared minus 6 dx should be the negative. So now distribute the values. So it will become negative 2x squared. And now we have to integrate. Would be 12x negative 2x3 over 3 plus 6x from negative 3 to 3. And from here on, you just have to work it out by yourself. So, yeah.